So you've probably heard about microservices. You've probably heard about cloud native as well. But have you heard about something called a cell-based architecture? Well, that's what we're going to be talking about today here on Cloud with Chris. Hello there, welcome back to another episode of Cloud with Chris. You're with me, Chris Reddington, and here we talk about all things cloud. Now, thank you folks for joining. We've got a super duper session today. We are going to be talking all about decentralized reference architectures for cloud native applications. And you heard in the intro there this concept of a cell-based architecture, not something we've heard of on the show, on the channel before. So I'm sure there'll be lots to learn in today's episode. We've heard of microservices, we've heard of cloud native. How does this concept fit into things? But before we jump in, you know the deal. If this is the type of content that you'd like, the more architecturally focused content, please drop a like, please subscribe, please hit the notification bell, because then it helps us know what kind of content you prefer, what kind of content you'd otherwise prefer us to put on the show and on the channel here. So with that, let's just go ahead and introduce our guest for the day. We have got Asanka Abesingha joining us to talk about this. So let's switch over and introduce Asanka. Hey, good morning and good evening, Asanka. Two different parts of the world.
Yes, Chris. Good morning for you.
Yes, good morning. Thank you. How are you doing?
I'm doing great, and it's a pleasure to be here. Thanks for inviting me.
Glad to have you. Glad to have you. Very interesting topic. I think when I was looking through all the different proposals and session ideas, this one certainly caught my eye. So I'm excited to be talking about this one today. So I guess before we jump into any of that, best to start with some introductions, Asanka.
Yeah, sure. So I'm Asanka Basing, and I'm the Chief Technology Evangelist at WSO2. So a little bit about WSO2 before introducing myself. WSO2 is a technology company that we provide API management, integration, and identity and access management solutions that you can run on premise, as well as we have cloud offerings as well. So all these middleware is open source that you can download, and then the business model tied up with the subscriptions and supporting services that we provide. So we started the company around 16 years before, when service-oriented architecture was the mainstream.
Yep.
And then with the evolution of the technology, now we are supporting cloud native and microservices related architectures as well. So about me, I'm coming from product engineering and product architecture background, and with the experience I gained, I started the solutions architecture team at WSO2 and ran that function for 10 years, and then thought of little bit change and help to drive the vision of WSO2 and helping to tell the story about WSO2 in a different way. So that's where I started working as the chief evangelist and spreading the story at the moment.
Excellent. No, great story, and great to hear the journey that not only the company has been on, but you've been on as well. You know, product engineering, going into the evangelism side. There's a lot of awesome stuff to talk about, even in that as well. But, you know, I guess not the purpose of today's discussion. I'm sure we can dive into that at some point, perhaps. But decentralized reference architecture with cloud native sounds very fancy. And when we talk about cell-based architectures as well, sounds fascinating. So where is the best place for us to start?
Yeah, so I think best place to start with why, because I think the concept of a reference architecture plus I think there's understanding of the industry, microservices architecture, and cloud native concepts are addressing most of the issues, but that is not the reality. still architects are struggling to figure out most of these concepts, as well as microservices creating another set of problems with the decentralization. So why we created this, mainly based on what we learn from our customers as well as the pain points the architects inside these organizations were facing. So that is the key motivation factor. And the number two, when you look at the reference architectures, most of the reference architectures are not reference architectures per se, those are reference implementations. Why I say that, most of the reference architectures are explaining how you can build a specific solution by utilizing a specific vendor technology. So I thought it shouldn't be that way. It has to be completely vendor neutral and technology neutral. So that was the second reason. And then the next motivation factor was these three components in application lifecycle: the architecture, development, and DevOps. Those are running in three silos, and there's no common thing that you can take from the architecture into development and into deployment. So I was looking for something common that we can utilize. And then the next key factor is, if you look at people who's using microservices heavily, they looked at the governance factor as well. And that's the concept of federating microservices, because you have to write group of microservices and then group them based on these two pizza teams or autonomous teams that you are involved in the development, as well as how you can create these boundaries using the domain-driven design. So I looked at all these aspects and then thought, there's something I can contribute to the industry, and there's a gap. So that's where the reason for developing something like this came into the picture. And to address all these reasons on developing this reference architecture is what I have addressed in this specification, as well as the implementations that I have already contributed with many organizations as well.
Excellent. And there's a lot in there that you said that resonates, like the piece around the architectures typically being for a specific implementation or using specific technologies or even solving a particular problem. I think when we see microservices architectures, there's always examples, right? And the canonical example, I think, is like the retailer example, where you have the shopping basket and you have the cart, or you have the order processing system, and all these different subsystems effectively that overall make up the solution. And it's not so often generic terms. You often see like some containers there or some other kind of technology. It's not abstracted away, is it, and thinking of the generic terms. But I guess what is maybe interesting and something we should explore for a moment, just in case for the listeners, is some of those challenges with microservices. Just explore that a little bit more, because I guess some of the listeners may come from more of an infrastructure background and an app development background, perhaps, so not understand some of those challenges. So I guess in a nutshell, microservices, what we're talking about is very small services that are there and designed for a specific use case or a specific scenario. And not going to go into the definition of that in this call. There's lots of calls, for example, which do this on their own and could take an hour. But using domain-driven design to really scope the boundary of what the scope of work is of that service. But the challenge you get typically, and I'm assuming this is where we're going with the problem you're trying to solve here, is you've got so many different services to start kind of choreographing and communicating and coordinating with, that actually it starts becoming really challenging and overwhelming.
Exactly. So I think you're exactly correct there. And the scope is the fundamental thing, not the size. So you have to like derive the microservices based on the scope. And I think domain-driven design giving a very good framework for architects and developers to think through and identify the scope as well as the bounded context, that how you can communicate between different domains. So the primary problem I see, the first problem is that like how to define these microservices within the organization. So that's where I think the architects and the developers should have a proper domain knowledge about the business to do this correctly. And I think that's where they can get the domain experts involved in the that exercise. And I highly promote this concept of a business architecture. Without doing traditional business analysis, do a business architecture and then define this microservices. So that is the first challenge. Second challenge is basically how you manage these microservices, because now you have many. You might start with 10, it will grow to 100, and then it will grow up to thousands of microservices. And this concept of the Death Star from Uber to Netflix, that they have all these trillion of microservices running. So how you are managing it, it's a typical problem. So this governance piece of managing dependencies, managing boundaries at the deployment level, and then how you have a proper life cycle about identifying the usage and how you can kind of like decommission a set of microservices when it is not using. All these are challenges, and when it comes to development, we might not think about it, but when we run real production systems using microservices, all these challenges are coming. So that's where we have to have a proper architecture, and then we have to have a proper governance model around these microservices to address those issues. But then again, it should not go back to this layered architecture with center of excellence teams. We have to give the autonomy with some governance enforced by these platforms that will handle microservices from design to development and into deployment. So I think that is where the challenges are coming, as well as development teams spending a lot of time to realize this technical debt that you have in this stuff. And I think they are not spending enough time to build applications. That is what the business required. So how we can simplify is what as the technology leaders in the industry we should do and help these organizations. So that is how I see the problems as well as the current landscape that we see in with the microservices coming as the mainstream architecture style.
Gotcha. And yeah, it certainly doesn't come without its challenges, and I think that's the case with anything. You know, with opportunity, there are potential challenges, and I think the risk of someone who's maybe not mature going down that microservices journey is just creating a distributed monolith, right? You know, you've gone away from the monolith, and now we're just spreading it elsewhere and making probably an even bigger challenge for yourself, to be honest, because you've now got a different operations model to deal with on top of that. So yeah, I'm really intrigued to hear about the model that you're proposing and pulling together here, Asanka.
Yep. Yeah. So I think that's where the cell architecture concepts are coming from this root of these problems, and I think you as well as the audience might be interested about why the term cell used here as well. So there's a background story behind that. Basically, now these cells kind of create complex systems, and every human being and every like a live thing built with cells, and it has a nice concept of a membrane and then the other particles of the cell. So I thought that's a really good way to articulate the microservice architecture as well. The things inside the domain is the components inside the cell, and then there's a gateway which act as the membrane that will do the communication within the components inside the cell as well as between two domains. So that was kind of a really good analogy to start and building the architecture. And while working on the paper, I realized that there's a lot of parallels between biology, system biology, and then this cell-based architecture.
Love that analogy. I'm a big fan of analogies on the show and using them where we can. And that idea that, as you say, you've got your basic building blocks, which are these individual cells, and they'll come together and form something bigger than themselves, right? I think is a great way of putting it. And the membrane idea as well as the gateway is interesting. I think when I read the proposal, I thought of cell, in like kind of cellular communications, and you got those hexagons, and you typically have them all next to each other slotted. That's kind of where my mind went first off. So that's I like how the analogy.
So it is connected, because now some of the concepts I got it from that network or the telco cells as well. Now, if you look at the specification, there's a concept of this control plane, then the data plane and the management plane. So that is coming from the telco side, but it is mainly focusing on this system biology cell and biological cell. But I think those some of these concepts inherited when these telco cells introduced and got to the market. So I think there's a good synergy in between those concepts.
Perfect. See, now what I'm thinking in my mind is teaching anyone microservices, we need to get rid of the shopping cart analogy. We now need the human body analogy. I think that's what we need to go for.
Exactly.
Awesome. Excellent. Cool. So then we've, I guess, established then we're talking about this architecture, which is loosely based off the concepts, of cells in biology then. So let's explore that a bit more.
Yeah. So now if you look at enterprise, like you have many systems and you are building systems as well. And I think the building part is really important, because software is the differentiator for any organization, and the software builds your differentiation. So you can't buy software because of that. So I'm not telling you shouldn't buy. You should buy whatever the common features, like the CRM system, HR system, all these things you should buy, and then build that unique experience for your end users internally. So that's where the new application development coming into the picture. But then again, you can't do everything greenfield as well, because we have these data and systems we purchased during last 2 decades, and we can't do an overnight shift to a completely new greenfield. So we need to have a way of tackling both sides, and then do the application modernization while we are reusing the existing applications and data. So cell-based architecture supporting the new microservices to group, as well as it creates a way to kind of encapsulate the legacy systems and put a API gateway in top of that, and make those legacy capabilities access via an API. So you can have a legacy cell there as well. So like that, we have defined different type of cells in the architecture. That you have channel cells at the top. Those are the end use applications. Like I'll give 3 examples of channel cells. One can be a mobile applications, number 2 can be a web application, and then third can be an edge, like a IoT applications running inside a device. Those are channel cells. And then you have like legacy cells that I explained earlier. And then you can have external cells, because some of these systems are not owned by the organization. As example, a SaaS application that they have subscribed is part of the organization capabilities, but then again, it is an external thing. So we can treat it as a external cells. And then there are logic cells. That's where the microservices will come and play a role, that you build all your domain services and domain logic inside those logic cells. And there can be identity cells, and then there can be data cells as well, because the correct way of doing microservices is having these data storages with the microservice, but in some cases we might have to share data store within a domain, and in some cases we might have to use a shared database as well because of the system dependencies that we have. So all these type of different patterns can be supported by using the cell architecture. And to optimize the usage and the latency, we introduced this concept of a local data plane and a local control plane, which is running inside the cell, as well as there's a global control plane and a global data plane that basically doing the global level communication between cells. So having these clear two layers helps to have a global level of policies and then global level of communication, as well as provide a lot of autonomy for these teams to do the development and do the communications within the cells as well. So that is how the communication works. So that two-tier communication provide a lot of flexibility. Like you can have your observability, security local to the cell, as well as if you want to utilize system level capabilities, you can utilize the global control plane and the data plane as well.
Gotcha. And there's lots in there to unpack, but in a nutshell, what I like is a lot of the things you said about, the different types of cells. You have like a mobile cell, identity cell, these different types of cells. You've got your legacy, products you're bringing along, those cells. In my mind, what I was doing as you were explaining that was kind of thinking of, if we were going down to the solution level and looking at an implementation, some of the patterns that it would map to, and I'm thinking of things like backends for front ends, strangler patterns, facade patterns, and all of these kind of things that we know from the industry. And I can see very clearly how those concepts map back to some of those clear patterns that we've already got established. And it's interesting because, again, now rather than thinking of a technical implementation, even though I just, of course, said some solution, different design patterns, my brain is still kind of wiring to thinking about cells in biology and thinking about how these cells communicate, not these different microservices anymore, if you go down the microservice route. So I really love the analogy. I love how it's how it holds to all of that.
Yeah, exactly. So you are exactly correct there, because you can have those low-level technical patterns at the second level that you design these domains using cells. And then within the cell, you can have any of these cloud native patterns, microservices patterns introduced and then implemented. And I think the beauty of this concept, it's nicely mapped to Kubernetes as well. When it comes to the deployment. So in a nutshell, a component is basically a pod that you can scale that particular component within a pod. And then the cell can represent in two ways. One is you can use a namespace in Kubernetes. But if you are going for the next level, you can define a CRD for the cell, and then have all these policies injected when you create the CRD. So those are few examples how you can leverage like systems like Kubernetes and implement this. But then again, it is not just Kubernetes based on whatever the infrastructure that you use. It's just a matter of script it and then define it how you want to deploy and how you want to group this. And you can get help from the DevOps engineers to define these deployment scripts for you.
Sure. Good. And I guess the part we've talked about there, I guess, is more targeting the governance from an organization perspective. So how we kind of think about all of those different microservices which are in the solution, in the system, if you like. And I guess one of the other angles we talked about earlier was the communication between the microservices as well could be challenging. And I guess typically when we think about microservices, we've either got some kind of central messaging system, we've either got APIs that we can kind of call and to find contracts, so high cohesion, low coupling. How does that all fit into this model then?
Yeah, so again, it depends on the implementation.
Sure.
So I can tell a few options. Like, so one option is use an extended service mesh concept. So because this is more than service mesh, that you have to have so like a local service mesh, local mesh within the cell that will do all the wiring and do the communication in between the microservices. And then there's a global mesh that will be doing the communication in between cells. So that is one way of handling this problem. The second way is basically, and the second and most popular way is use protocols like gRPC to handle the communication within the cell, within the microservices inside the cell, and then have HTTP as the way to communicate in between by exposing these things as standard APIs. But then again, like with GraphQL and like async APIs coming into the picture, it is not only limited to this HTTP. You can have any of these protocols as the way, and as the way you expose the APIs. And I would say like you can use request response, then eventing or publish subscribe, or even you can go for streaming as the way you expose these APIs from the cell.
Gotcha. And I guess it really depends. To stretch the cell analogy even further, we've got different types of cells in our body performing different functions, our red blood cells, our white blood cells, etc., etc. So each of those are going to work in slightly different ways. They're going to have certain specialties and certain areas they focus on. And I think the analogy is the same with those microservices. They'll all have their different specialties. They'll all have different ways of working. But overall, there is almost that glue that is there between all of these, where it's that consistent contract, I guess, between the different microservices, and this is how we communicate. The cells evolve and change over time, but actually the way they communicate doesn't fundamentally.
Exactly, and the glue is APIs basically, so that glues everything. Like intercell and intracell communication is completely done with that layer of APIs.
Gotcha. And I guess for anyone who's been kind of watching the video rather than listening in, maybe if we just bring up a couple of slides, for example, if there's any relevant, just for some visual aids, because I think that's always good with some of these more abstract topics, because I'm on the same page. Definitely, I'm on the same wavelength here.
So I think this is a good slide to watch about some of these concepts that I explain about the global mesh, local mesh, and then this local control plane, data plane, and every cell contains a cell gateway. That's the membrane concept that I explained. And if you notice, there's a global control plane and a global data plane as well. So that is how this communication happens. And then I would like to highlight one more thing about the communication, how the ingress and egress calls will work. Um, so let me pull up this. Yeah, so basically the concept is tied up with any ingress call should go through the gateway, but egress calls can go directly from that microservice to another gateway of a different cell.
Gotcha.
So this is the one major difference between this hexagonal architecture and cell-based architecture, because in the hexagonal architecture, there's this concept of adapters that will do the egress calls as well. But for me, it is a very costly thing. Like if you want to do a egress going through the same gateway, will limit and then it will add more latency to these calls. So why I prefer to do or prefer to allow the egress calls can go from that particular microservice to another cell gateway. Again, it will go and hit another gateway, right? So we can enforce those policies at that particular gateway, as well as if you want to capture observability data, you can do that using that cell gateway as well. So that is how the egress and ingress calls are happening. And to support that, you can have all these sidecars, adapters, ambassador, those type of container and microservices patterns as well.
Perfect.
And let me go through some of these capabilities. So this gateway pattern is adding some more advantages as well, especially the governance as well as enforcing policies, and it automatically enable observability, because as I explained, the communication will touch some kind of a gateway, the same cell gateway or a gateway in a different cell. So that way we can manage and control all these communication and governance capabilities. And I explained about the security part. So this is how the security work. Everything can happen locally, or it can go and fetch data from the IDP in the global control plane. And to optimize some of these security calls, we can cache some of the decisions in the local control plane and optimize it as well.
Gotcha. I really like the analogy. Like, my brain has already been going off in tangents here, thinking of stretching the analogy and where it can go. Like, something I'm really big on in this channel and in general, to be fair, is requirements-driven architecture and requirements-driven design, and things like your non-functionals and understanding criticality of things. And I think when you get into a microservices-based world, one of the things you get into is, hold on, not everything is equal. Not all of our microservices have the same criticality. So back to the shopping cart analogy, if our main order processing service goes down, for example, well, the business stops making money. That's a bad thing, which isn't as important, let's say, as the random back-end process, which is doing reconciliation, for example, or something like that. And I think the same analogy holds here, right? If we think of the body, if we're in a battle and an arrow gets shot at you or something, and it happens to go to your arm versus your heart, obviously that's taking that body analogy a bit further, I guess. But again, different parts of that system are more critical than others. So my mind works in strange ways, but it makes sense in my mind.
Yeah, so completely agree with that. And one thing I would like to highlight about the developer experience, because this doesn't change the developer experience. So developer will do the fun thing, like he or she will do the create the components and then commit, test, and debug. He or she will go through that, and when they push these changes, these cells will created and then get deployed and go through that life cycle. So he or she will not experience any difference of usual developer flow. And then so that kind of is a added advantage because you don't have to change. And then this the agility part of this. Now if you look at this concept, now each and every component inside the cell, it has a version, as well as you can have a version for the cell. So that way, like, you increase the agility, and I call it as a structured agility. Now you have the agility within a component, you have the agility within a cell or the domain, as well as you have the agility at the enterprise level. So it's a 3 levels of agility that you will have with this architecture. And then if you look at the enterprise level view, this is how it looks like: bunch of cells, and then the type of cells that we explain will come here, like logic, integration, legacy, external data, identity, and channel. So these are some types of cells that I identified based on the use cases that I handled. But then again, it's like we can introduce more types in future if required, so that extensibility is there as well.
Yeah, it's interesting. I guess the one that I'd be interested in exploring there that stands out a little bit out of those is the data one, because I guess there's always this, religion versus politics discussion, right? Some things that sometimes maybe you should never have, is whether you have a data store per microservice or whether you have a data store centrally, and there's still a lot of debate with people around that. So, I guess what was the thinking there of having the data as a separate cell in its own right?
Yeah, I think it depends on the flexibility we have, right? Because in most of the enterprises, the system of record layer already exists. It's somewhere out there. So still you can have this, the correct way of doing it by having a local storage per microservice, by having a data lake kind of a concept, or a data mesh kind of a concept. Gotcha. That you replicate the system of record level data into a very lightweight data storage, like as example Redis or something like that, caching or lightweight data storage with name value pairs, but it will synchronize with the central data store. But if you are starting greenfield, then you have the flexibility to have these local data storages, and then use like a message broker as the event sourcing to do the communication at the real time of these data sets between microservices as well. So it is basically not the correct way, whether how much you can afford with the constraints that you have with the existing data, as well as the flexibility that you have, because without existing data, you can't provide much value for your consumers. So we need to take a look at that as well, and then have this balanced approach.
Yeah, it makes complete sense, and I think it's a very pragmatic approach as well there, right? I think, again, it's very requirements driven, being realistic. There's always this nirvana or this ideal world from a microservice design perspective that you have that database or data layer within that microservice. But as you say, you're likely bringing along some, I wouldn't even call it legacy, but some insights, some knowledge there along as you start building that solution and working out that model along the way, I think is key there.
Exactly.
Excellent. I really like this analogy. Really like this
and
analogy.
I extend this concept, Chris, a little bit, so that I call it as a cellular enterprise. That basically you look at it as the entire enterprise with cells. Like, there are human cells, and there are business cells, and then architecture cells, and deployment cells like that. So all these things can map into cells, and then that's where the cellular enterprise comes. I think there's a term called composable enterprise coined by Gartner. Similar concept like how you can have this unit of working groups and then executable units organized as cells. That's how I think we can kind of take it to the next level by having this concept of the cellular enterprise.
And it just makes so much sense. Like, you know, when you go down from quite literally the individual cellular level, and you look
Yeah,
at things like, you know, thinking about the cells which are protecting you from threats or viruses or whatnot. Similar analogy, right? We have threats, we have viruses, we have challenges in the technology world. How do you adapt to those? Well, you just, you know, evolve, you patch things, you upgrade things, you make sure that they are protected against those later threats. You keep updating, you keep growing, you keep evolving, and that's not just at a cellular level. We're all growing, we're all evolving and changing, and as you say, you've got that kind of cell-based concept, no matter if you're looking at that very microscopic view or looking at it more of a macro level then as well. Um, yeah, really, really great, great analogy. Awesome. Excellent. So I guess, you know, are there areas that you think we should maybe cover off that we haven't delved into yet at all, Asanka?
I think we covered all the components. I think the areas that we should focus, and I highly encourage to read the specification because it provides a lot of insight. So that is where this URL, and it's a Git project, the specification done using Markdown and released under Creative Commons 4.0. So feel free to contribute and provide feedback, even criticize, and then be part of the community. And not only that, I have authored methodology as well, like how you can implement this, basically describing in the methodology, because what I believe architecture and the culture is the foundation. So the architecture addressed by the reference architecture, but you need to do this cultural change. So that's where the methodology trying to address most of these concepts, because agility is a buzzword again. And I believe most of the agile methodologies are not agile by itself. So how you can kind of have a proper approach that will fit into your organization, it's where this methodology is explaining. So I think those are two good resources to go through that will provide a lot of insight. And I'll put some of my contact details as well. Like if somebody is interested, then they can connect with me, and then I'm happy to provide more insight and guidance on these concepts as well.
Excellent. No, Asanka, awesome, brilliant, brilliant session there. So I guess if we had to boil it down to maybe your top one or two thoughts that you want people to take away from all of this, what would it be?
Yeah, I think the first thing is the business and technology alignment should be there with all the applications and software systems that we are building. So that's where you should have an outside-in approach that look at what your consumers required, how you can contribute to the value stream. So that's where these domain concepts are involved. And then have transform it to a business architecture, and then take it to the technology architecture, and have a proper exercise there, and then work in these autonomous teams to implement these things. And then again, architecture is not something concrete. It has to be evolve and go through this iterative architecture approach and keep on improving. and try to connect these three groups of architects, developers, and DevOps, because you can't operate separately like we used to do in the layered architectures as well as layered organizations. So we have to work in this all three groups together with a common objective, and think in cellular terms, not only at the architecture level, at the organization level, business domain level, and utilize it as a foundation to build your systems. And I think it will provide solutions for most of the teething issues as technologies we are facing day to day.
Excellent. Asanka, brilliant session. Really enjoyed that. And as I said numerous times, I love the analogy. Really love the analogy. So great work. And thank you for coming on and presenting about it. Really
yeah, it's a pleasure. Yeah, it's a pleasure, Chris. And thanks for inviting me. Thanks again.
Thank you. So there we go, folks. We have been looking all at decentralized reference architectures for cloud-native applications. And that, wow, what a great session, looking at all of these kind of cell-based concepts and how we can actually extend those concepts and analogies into these technical architectures, effectively taking that outside-in approach, thinking from that business lens, and ultimately, eventually, arriving at that technology architecture. And lots of things that resonate with things we've spoken on the channel previously, like requirements-based design, for example, not rushing into the technology too quickly, understanding the wider context. You can see all of that shining through what Asanka was talking through there. So, great session. I definitely recommend you go back and listen to and watch that again, because I'm sure there's more insights you'll pull out as you listen to that again. So you know the deal. If you've liked this session, please hit the like button, please hit subscribe, please hit the notification bell so you know as soon as there is new content available for you. And we will have Asanka back in the very near future to talk about another topic as well, so stay tuned for that one. So otherwise, folks, thank you for listening and watching in today. Keep safe, stay healthy, and until the next one, bye for now.